Hi guys, let's look at the next question. But before I start the next question, let's quickly revise the formula that we've done in this exercise till now. So the first one we talked about was density is equal to mass upon volume. And the second one that we talked about was relative density of a solid is equal to weight in air upon weight in air minus weight in liquid multiplied with Rd of liquid. These are the two formula that we've talked about. Other than that, in the previous exercise we had done upthrust is equal to volume of solid which is under the surface of liquid multiplied with density of liquid into G. So these are the formula that we've talked about. Let's solve another question. So it says a body weighs 20 gram force in air, which means weight in air is equal to 20 gram force and 18 gram force in water. So weight in water is equal to 18 gram force. Calculate relative density. We know, let's call this W1, let's call this W2. We know RD would be equal to W1 upon W1 minus W2 multiplied with RD of water. So in this case, this would be 20 upon 20 minus 18 into 1, which is 20 upon 2, which is equal to 10. Therefore, relative density of this body is 10. Very simple. Let's look at the next numerical. The next numerical that we do is question number 13. It says a solid weighs 1.5 kilogram force in air and 0.9 kilogram force in a liquid of density something. Calculate relative density of the solid. So let's just figure it out. Point number one, weight in air is equal to 1.5 kilogram force. Number two, let's call this W1. Weight in liquid is equal to 0.9 kilogram force. Let's call it W2. And in the formula, I'll need the relative density of the liquid. So relative density of liquid would be equal to 1.2 into 10 to the power 3 kilogram per meter cube upon the density of water, which is 1000 kilogram per meter cube. So this and this gets cancelled. So relative density of liquid is 1.2. Now let's put all these information in the formula. We know relative density of solid would be equal to W1 upon W1 minus W2 multiplied with relative density of liquid. Substituting values, what we get is relative density of the solid would be equal to 1.5 upon 1.5 minus 0.9 multiplied with 1.2. So this is 1.5 upon, that's 0.6 into 1.2, that's times 1, that's times 2. So relative density is equal to 3. Simple question, as long as we could remember the formula and we remember to convert this into relative density. Good. Let's look at the next question. The next question that we do is question number 14. So question number 14 says, a jeweler claims that he makes ornaments of pure gold of relative density 19.3. He sells a bangle weighing 25.25 gram force to a person. The customer weighs the bangle when immersed in water and the weight is 23.075 gram force in water. With the help of suitable calculations, find out whether the ornament is made of pure gold or not. So let's look at the information for the customer. So for customer, weight in air is given equal to 25.25 gram force and weight in water is given equal to 23.075 gram force. So relative density of gold in bangle would be equal to, let's call this W1, let's call this W2. it would be equal to W1 upon W1 minus W2 multiplied with relative density of water. So this is 25.25 upon 25.25 minus 23.075 multiplied with 1. Now we'll have to subtract. That's 23.075. 10 minus 5 is 5. 14 minus 7 is 7. 1 minus 0 is 1. 4 minus 3 is 1. That's 1.175. This is 23, right? No, so that's not 1. This is 2. 5 minus 3 is 2. My mistake. Let's confirm. 10 minus 5, 5. 14 minus 7, 7. This becomes 1. 1 minus 0. 5 minus 3, 2. So this is 25.25 upon 2.175. Now again we'll have to divide. So let's look at this. Relative density would be equal to 25250 upon 2175. Taken the decimal out. So this is 5 into 4, 20. That's 5 into 3, 13. That's 5. This is 5050. Yes, this is fine. Let's divide by 5 again. 1010. If 5 into 8, 40. 35. So 5 into 7. 15. Okay, so now we'll have to divide 1010 divided by 87. 187. That's 11 minus 7, 4. 9 minus 8, 1. That'll be again 1. This is 87. 10 minus 7, 3. 13 minus 8, 5. Put a decimal, 0, which means 87 into 5, 6. Let's try 6. This will be 6 into 7, 42. 48 plus 4, 52. So that's 6, 522. That's 10 minus 2, 8. With a 0, again 0. So, which means our relative density is 11.60. Let me erase this. It'll give me space to write. So, therefore, RD of Bangle is equal to 11.60. Now, the reported relative density is 19.3. So, since RD Bangle is less than RD Gold, therefore, the ornament is not made of pure gold. Perfect, because the RD is different in both these cases. Intelligent customer. Let's look at the next question. Next question is question number 15. It says a piece of iron weighs 44.5 gram force in air. So let's just do the calculation. Weight in air is equal to W1, which is 44.5 gram force. Density of iron is given. So point number 2, density of iron is equal to 8.9 into 10 to the power 3 kg per meter cube. Find the weight when immersed in water. So for that we need to know the relative density, correct? So which means relative density of iron is equal to 8.9 into 10 to the power 3 kilogram per meter cube upon density of water, which is 1000 kilogram per meter cube. This and this gets cancelled. So relative density of iron is equal to 8.9. Done. Let's apply it in the formula, but before that, let's write the assumption. Weight in water, that's what we need to calculate. Let it be equal to W2. So we know relative density is equal to W1 upon W1 minus W2 multiplied with the relative density of water. In this case, let's substitute values and see what we get. So relative density we just calculated as 8.9. This is 8.9 is equal to W1, which is 44.5 upon 44.5 minus W2 multiplied with 1. Let's cross multiply. So 8.9 into 44.5 minus W2 is equal to 44.5. Divide both sides by 8.9 because this is divisible by 8.9 and this is also divisible by 8.9. 89 into 5, that's 445. So this is 8.9 into 5. So dividing both sides by 8.9, what I get is 44.5 minus W2 is equal to 5. Yes, this is correct, which means 44.5 minus 5 is equal to W2, which means weight 2, which is weight in water, is equal to 39.5 gram force. Therefore, weight in water is equal to 39.5 gram force. Done. Let's look at the last question of this exercise. The last question is question number 16. So question number 16 says a piece of stone of mass 15.1 gram. So mass is equal to 15.1 gram is immersed in a liquid and it weighs 10.9 gram force. So let's calculate the weight in air. Weight in air would be equal to 15.1 gram force. This is, let this be W1. So weight of stone in air already done. That's the first part of the question. Next, volume of stone we'll calculate, relative density of stone, relative density of liquid. So point number 3, weight in liquid. Let that be equal to W2. In this case, this is 10.9 gram force. Number 4, weight in water. Let that be W3. This is given equal to 9.7 gram force. This is the information which is given till now. Let's see what do we need to calculate. So relative density of stone we can calculate. Should be easy to calculate. Weight in air. Okay, let's calculate relative density of stone first. So point number 5. A relative density of stone would be equal to weight in air upon weight in air minus weight in water multiplied with relative density of water. Let's substitute values and let's see what do we get. So this is 15.1 upon 15.1 minus weight in water is how much? 9.7 minus 9.7 multiplied with relative density of water, that's 1. So that's the relative density of stone. We'll need to do some calculation. So this is point number 6. RD would be equal to 15.1 minus 15.1 minus 9.7. That's 11 minus 7, 4. 14 minus 9, 5. So this would be 5.4. 5.4. Let's delete this. I'll need space to work. So we'll need to divide now. 5, 6, 7. Oh, can't be divided. 151 divided by 54. So that'll be 2. That'll be 108. So this is 43. Put a decimal 0. So into 8. No, not 8. That will become more than. So that's 7. That'll be 54 into 44 is the 32. So 7 into 4, 28. 7 into 5, 35 plus 2, 37. So this is 2.7. This is 378. Subtract 10 minus 8, 2. 12 minus 7, 5. That's 0. Now this would be 9. So 2.79. So relative density is equal to 2.79. They haven't said, since the question is given in one decimal place, I can round it off to 2.8. So the relative density of the stone is 2.8. So that part of the question also done. Let's look at the Next part of the question. Next part of the question says relative density of liquid. Okay, so number 7, relative density of stone would be equal to weight in air upon weight in air minus weight in liquid. In that case, we have taken it as W2 multiplied with relative density of liquid. That's the common formula that we've been using. Let's substitute values. Relative density of stone we just calculated as 2.8 is equal to weight in air, which is 15.1 upon 15.1 minus weight in liquid is 10.9 multiplied with relative density of liquid. That's what we need to calculate. So this would be 2.8 multiplied with, that's 4.2. Yes, this is 4.2 is equal to 15.1 into RD of liquid, which means RD of liquid would be equal to 2.8 into 4.2 upon 15.1. Okay, so we'll have to multiply and do this calculation. So not divisible by anything. So this is 28 into 42, that's 2 into 8, 16, 4 plus 1, 5, 4 into 8, 32, 4 2 is 8 plus 3, 11. That's 6711. So this is 1176. So this is 11.76 upon 15.1. Now we'll divide 1176 divided by 151. That'll be 8, I guess. Let's try 8. 8, 5 into 8, 40. 8 into 1, 8 plus 4, 12. No, that'll be 7. 151 into 7. 7. 7 into 5, 35. 7 into 1, 7 plus 3, 10. So that's 0. Not 0. Yeah, 0 point, because this is 11.76, rather 117.6 because we've removed the decimal. Not 11. That's let me just write it here so that it is clear. I can write this as 117.6 upon 151. Correct. So that's 0.7, and this is 1057. 16 minus 7, and that's 9. 6 minus 5, that's 1, and this is 1. So that's 119. Let me erase this, very less space I have. Okay, doesn't matter. So this is 0.7. Again, I'll put a 0. So this would again be 7. This will be again 1057. So my answer is 0.77. So relative density of liquid is equal to 0.77. If you want to round it off, this would become 0.8. Relative density of liquid would be 0.8 in case we round it off to 1 decimal place. So that finishes this part of the question. That still leaves the volume of the stone. Let me erase the first few things that I've written. We know density is equal to mass upon volume. We know the mass, we know the density, we can calculate the volume. So if I can erase the first part of this question, which is here. Okay, so this is relative density of stone is equal to 2.8, which means therefore density is equal to 2.8 gram per centimeter cube. We know density is equal to mass upon volume, which means volume will be equal to mass upon density. In that case, 15.1 upon 2.8, which is nothing but the same calculation which we did, which will be 5.4. Therefore, volume is equal to 5.4 centimeter cube. So the last part of the question also done. That finishes this video for me and the exercise. Take care, be safe. I'll see you with the next video. Bye bye.